And number 10, what are the troops? There's two different ways that we can fight off a foreign invader. We can either call on cells to do it, or we can call on antibodies. So cells or antibodies. That's how we fight off specific foreign invaders.
They have our cells, antigens, and lymphocytes. Is that?
Wait, say that again?
They have our cells, in parentheses, antigens, and then the other one is lymphocytes.
Half. The lymphocytes will work, but the other one won't, because it would be antibodies instead. Yes, I'm sorry, Judy. And what? Good enough, because the B lymphocytes will make antibodies. So good. And killer T cells are certainly part of our cellular response. Good. Chastity, do you have a question?
Blood and lymph nodes.
Say that again.
Blood and lymph nodes.
No. Be a little more specific. Okay, put the number correct at the top. Oh, I'm sorry.
Macrophages or T cells.
We'll call it half, because those were all cells that will be used for specific, but we didn't have antibodies, so let's call it half. All right, put the number correct at the top, circle, jump to the right below. And then you can pass it to your right, please.
Trying to get back to my damn page.
Do I have all the quizzes?
It's like a 10 every time.
That's before. I just wait to figure
All right. So, same question as before the quiz. Any questions? Everybody cool? Quiz go okay? Trying to divide this up, trying to simplify it a little bit from what the textbook has. So, this is my main introduction for immunity. Like I said the other day, this is actually a lot of good information, separating this out. There's just a ton of detail for each one of these. So there's whole courses in this stuff, whole courses in immunity or immunology. So what we're going to do is we're going to first start with just reviewing the players. All right, just reviewing the cells. So yeah, it's mentioned in the textbook in this chapter on 823, but really this is the stuff we did back in lab. When we did the blood lab and we did our differential count, we at least tried to take the time to look at blood cells and determine how many of your own blood cells were lymphocytes, or eosinophils, or basophils, and so forth. And there was that nice table, and I said, look at the table because it's got the pretty picture. I said, notice the functions, but we'll do it later. Later has arrived. Okay? Later is now. So the information that I've written up here on the slide is really from that table on 698 and 699. So you really don't have to scramble and write all this down. If you want to highlight some of the things that I colored, okay. But you've got this in the book. Just note those pages. All right. But let's slowly look at these for a second. These are the 5 different types of white blood cells circulating around in your blood. So we're starting with the neutrophils. They were the most abundant. I think I put that on the practical exam. So which was the most abundant in the differential count. So they make up 60 to 70% of your white blood cells, of your leukocytes. So now we're just going to focus a little more on what exactly do they really do. Well, they certainly chew up bacteria. They're working all day to help chew up bacteria. We encounter bacteria all day. Also, when called upon, they can form a killing zone. The technical name for that is this degranulation business. But essentially what happens is these cells produce a whole bunch of really nasty enzymes. They put them in their lysosomes. They end up secreting them out of the cell. So you've got these cells lined up and they're just spitting bad enzymes, really destructive enzymes, into a small area of the body. The body's kind of cool about walling off that area. That's not really mentioned on this slide here, but we'll wall off that little area. So this is an area where you can essentially get pus to develop. These lymphocytes, these neutrophils will help us develop pus. They listed in the table there about peroxide and hydrogen peroxide and some of these other free radical type things being secreted into the area. But the point is, if we've got some bacteria that we can't really chew up, we're just going to secrete a bunch of enzymes over top of this and just kill it. Just make this a nice little pus-filled area of killing zone. Eosinophils. Eosinophils were one of the very small ones. Remember, we had 2 large ones that took up most of your white blood cells, and then we had 3 smaller ones. Well, eosinophils were one of the smallest, only 2 to 4% of your white blood cells. But look at what they do. It's a little different here. When the body has produced antibodies, and those antibodies have stuck to some foreign antigen, seeing that stimulates these cells. These eosinophils, when they see antibodies stuck to foreign antigens, they chew them up. So they like to phagocytose them. They take them in, they destroy them with their enzymes. They play a role in producing some inflammatory chemicals as well. That's great. And then they are also anti-parasitic. So sometimes if there is a parasite in our body, these are the cells that will hopefully recognize it and deal with it. So they'll produce a little bit of their own killing zone, but not quite as popular as the neutrophil one. So there's aggregate and release enzymes. That's another milder form of a killing zone. All right, we good on our first 2? Wonderful. Let's look at the next 3. Basophils. Remember, they were the lowest. You usually don't see too many of these circulating in your blood. They can be out in the body, though. Just like all of these. All these white blood cells can get out. They're mobile. Remember, they have a nucleus. They have all the machinery of being a regular cell. So they're mobile. Red blood cells, they might get squeezed out of your blood, but they don't actively crawl out. White blood cells do. So even though there's very few in the bloodstream, there are plenty in your body. Basophils are very important in producing these 2 chemicals that I highlighted. Histamine and heparin. Histamine and heparin. This is really worth memorizing here. Is when we look at histamine, histamine is what we call a vasodilator. This chemical will talk to the smooth muscle in the wall of blood vessels and tell it to relax. That's going to bring more blood into a particular area. All right, it increases blood flow to a particular area. Heparin is an anticoagulant. In other words, heparin tries to block the clotting process. If you slow blood down in an area, it tries to clot. Heparin keeps that from happening. Right? That's kind of a good thing. All right, when we start to look at things like inflammation, we're going to increase blood flow to an area and it's going to get congested. We don't want it to clot. We still want it to stay nice and thin so that the white blood cells can climb out of our bloodstream. If everything clotted up, then they may not be able to move. So the text said something funny about prevents immobilization of phagocytes. Okay, it allows them to move. It prevents immobilization. It's a funny way, at least in my mind, it's a funny way to describe it. But what it does is it keeps them free to move. Our blood doesn't clot off in little capillaries. So 2 very important ones. Increased blood flow, and essentially the heparin is thinning the blood a little bit. It's one way to look at it, because that's how we use it medically. It helps to thin the blood a little bit, keep it flowing. We'll use that in a minute. Number 4, lymphocytes. Lymphocytes were our second most common of the white blood cells. So neutrophils were first, lymphocytes are second. And you've already heard, we have lymphocytes all over the place. In our spleen, in our tonsils, in our lymph nodes, in our thymus. Again, just what you measured in the blood is just that, what's in the blood. But many of these white blood cells are out in the body. Lymphocytes are really good ones. Lots of different forms of lymphocytes. I think they're actually still categorized as lymphocytes. Nowadays, they refer to some of the lymphocytes as natural killer cells, NK. You'll also hear killer T cells used. Right? And I've mentioned T and B cells a little bit up to this point. So there's lots of different lymphocytes. So don't get hung up on just this NK. The T cells, the B cells, the memory cells, lots of interesting ones that we'll talk about. This is probably the most diverse group of the white blood cells. I don't even think I'll say probably. It is the most diverse group. And we'll see they have lots of interesting functions. But you see, what these will often do is they'll attack host cells. They'll attack your own body cells if they know the body cell is infected. Right? If they see that it's infected, for the greater good, they kill it. They will try to kill those cells. Right? So that's what we mean by it lyses, or it'll attempt to lyse or blow up host cells that are infected with viruses or cancers. These are pretty important cells. We hope these are working very well. And we will gladly sacrifice a few cells that are infected to prevent further infection. So we'll come back to more on lymphocytes in a bit. Lastly, monocytes. Oh, I'm sorry.
Are the T cells and B cells bad cells?
Are they what?
Are they bad cells? Like,
Bad cells? Oh no, they're great cells. We love them. We love them. I thought I mentioned this the other day. Maybe I didn't make it clear. The T cells, remember, they were the lymphocytes that spent a little time in the thymus to get educated, to learn what is self and what is not. And what happens when we get an infection, our normal body cell doesn't look normal anymore. So these cells kill it. Okay? The B cells were another form of lymphocyte, and when they're told, hey, there's a foreign invader in, if it's a foreign invader they recognize, instead of going and killing it, they produce antibodies. The B cells will end up doing that. So there's your kind of specific response right there. T cells and B cells. For cellular response versus antibody response. But we'll see it again. We'll see it in a couple more, so probably on Monday. So the last one, the fifth of our white blood cells, our defense cells, the monocytes. So of the bottom three, they were the most popular in our bloodstream. Right? 3 to 8%, roughly speaking. Circulating precursors to macrophages. That's exactly what I said before. These circulate in the bloodstream, but then they can be activated and crawl out of the bloodstream, and now we call it a macrophage. And physically changes shape. It gets a lot bigger, it looks a whole lot rougher. Okay? In the bloodstream, it's nice and round, so it can flow nicely. But once it gets out, it does change its activity, so we change its name. So monocytes become macrophages. A really interesting feature of macrophages is they function as APCs, antigen-presenting cells. Okay, if you really start thinking about the immune system as this constant battle that your body's undergoing, these are the real amazing warriors. When they encounter a foreign invader, they will do everything they can to kill it. And one of the last things they'll do is, I think of it like Braveheart. Remember the movie Braveheart? I love Braveheart. Okay, but remember when they killed the one prince and they cut off his head and they sent it back to the king, okay, to alert them, hey king, we're serious. Right? That's what these cells do. Is when they see a foreign invader, they take a piece of that foreign invader and they literally put it on their surface. Where their own ID badge is, they hang the head of the foreign invader that they've tried to destroy. And now they can go around to other cells and they can present that to them. They can show them, hey, here's who's invading us. So that's what we mean by antigen-presenting cell. Okay? It's a very important role because that helps us with specific immunity. These guys, macrophages, are really part of both systems, the general or the non-specific immunity and specific. So they'll gobble up something that they just know isn't normal. Then they'll put a piece of it on their surface and show it to other white blood cells to teach them, to alert them. Get ready, something's coming. Come. Okay. All right, so pretty cool. Very much warrior cells. We see them all over the place. So these are the major players, okay, in our immune system. That's what we said before when we were doing the blood. Red blood cells are carrying oxygen and CO2. The white blood cells are there for defense. So now you've got a little idea of the specific nature of their defense. Okay? There are other things used. I don't care about them. But because you may have heard of them, or I know you will in your micro class, interferon, complement, lectins, all these funky things. These are all essentially just little chemicals that can be produced that can help us fight foreign invaders. There are a lot of people now looking at these things for cancer treatments. They're saying, okay, if your cells go rogue and they're now a cancerous type cell, is there something that the body manufactures that we can use, that we can throw in there? So interferon is a big one right now. I keep hearing an awful lot about interferon therapy for cancers. But it's essentially producing some funky chemicals. In this particular case, this diagram shows you an example of one of these chemicals. It can be produced by the cell